Hi, my name is Blake Wyatt, and today I'm covering paper 3 for Complex 529. The paper is The Overwhelming Uncertainty in Self-Adaptation, an empirical study on PLA and CobRA. The authors of this paper are Yi Qin, Xiaoxing Ma, Yanxiang Tong, and Jingxin. This was presented at the 12th Asia-Pacific Symposium of Internetware in the year 2020. So, what is the problem? The problem that our authors are trying to resolve is what the empirical difference between PLA and CobRA is. Both PLA and CobRA implement proactive self-adaptation. The idea behind proactive self-adaptation is to not only consider the current environment of a service, but also predict future environments and what should be done now to accommodate for this. PLA and CobRA both also implement multi-objective optimal programming. Where they differ is that PLA uses an architectural-based approach which uses state machine-based model to describe the managed system and its running environment, while CobRA is a control-based approach, which uses reactive control to connect the managed system's input and output values and its adaptations actions. Still though, both PLA and CobRA have been reported to output very similar results when it comes to supporting self-adaptive systems. The objective in identifying the empirical difference between PLA and CobRA is to explain how these two different implementations are so similar when it comes to outcome, but are created by such different implementations. So, the issue that we're faced within the field of computing is that we have a tendency to accept that if something passes all applicable tests within an acceptable time frame, that it's doing the job effectively, rather than asking why and how this implementation gets to the conclusion. A prime example of such a thing is how we view mathematics. Although math is a very important part of what we do, we have a tendency to simply trust outputs of equations rather than understand the formula gives us an output. This is also an issue within the wider science community itself, to the point where the replication issue is starting to become a big deal. So having individuals that are willing to investigate and solve problem to a far deeper degree than what has otherwise been done before will lead us to develop better solutions for problems in the future. So the related word for this piece is other empirical studies. Several other empirical studies have been done about this field, about the performance difference in different self-adaptation mechanisms. The one that's named within the paper is Xiaoxing and others, who compared a control-based mechanism, SimCA, with an architectural-based mechanism, active forms. They reported that the architecture-based mechanism is better for systems that require low settling time, and a control-based method achieves better results in the presence of a runtime fluctuation. Gabriel and others also compared PLA and CobRA themselves, but from a much different point of view. They did it from the development of cost and runtime performance. They reported that both can achieve the same good adaptation control effect. How this paper differs from those is that it looks at PLA and CobRA's different implementation choices and their submodules, and find the difference in the performance in the different environmental workloads. So the main idea for this paper is that they want to solve two questions. How do the three modules PLA contribute to its effectiveness in supporting self-adaptation, and how do the different design choices in system modeling and environmental predicting contribute to the different performance of PLA and CobRA? And they also want to identify what aspects of proactive self-adaptation contribute the most to these. So how is this better than previous ideas, or looks into this? So one of the big things about this is achieving the objectives laid out would enable developers and researchers to further optimize for future implementations of proactive self-adaptation, which will lead to more cohesive and optimal designs. This will inevitably lead to faster, more stable, and less error-prone implementations of proactive self-adaptive systems. On top of this, meeting this objective will give us a deeper understanding of what occurs when self-adaptation is implemented in its current form. At this point of this paper being published, we didn't really have much of an idea of what module was having the largest impact on the overall design of a proactive self-adaptive system. By conducting these tests, it allows developers and programmers to have a better concept of what's happening when PLA and CobRA are being implemented into a system as of right now, and identifying shortcomings that can fall in the other services we develop. So the authors began their evaluation by setting up an environment. They went with SWIM, a simulator of web infrastructure management, to be able to send data into the environment. And they had on top of the SWIM infrastructure Rubus. Rubus enabled the authors to create servers at differing levels of quality. And Rubus can also be set up as a self-adaptive system of its own, giving a basic framework whose environment or workload can be easily modified to allow for testing of proactive self-adaptive systems to be placed on top of it. The test sets they established for the workload inputs for SWIM were two real-world examples, one being the World Cups dataset and the other being ClarkNet dataset. From here, they identify the differences between PLA and CobRA through having three different modules to be able to explain the aspect of these two different implementations. And finally, conduct an ablation test on the three primary modules of PLA and CobRA, and them to each other to see what each module achieves, and to compare them to the same study done in CobRA system as estimates that will be roughly around the correct point. The three modules are system modeling, environment predicting, and uncertainty filtering. System modeling. System modeling is where PLA and CobRA differ the most. System modeling is about managing the relationships between systems' inputs, outputs, and adaptation controls. PLA treats system modeling as a white box, being precise and accurate with these values, where CobRA assumes the managed system is somewhere near the equilibrium point despite uncertainties, treating it as much more of a black box. Due to the environment chose, a large amount of fluctuation is possible, which could have a negative impact on CobRA, so both extreme and minor changes are going to be tested further within this paper. Environment predicting. Both CobRA and PLA handle environment predicting differently. PLA assumes that future environments should be able to be predicted upon by past states, and it constructs a probability tree of future environments to be able to guess the next based upon their current and previous. This allows it to establish adaptation strategies. CobRA instead uses a closed-loop feedback control. This means that it doesn't predict future environments, but instead feed forwards its measurements to improve its possible predictions of the current based upon the current indicators. Uncertainty filtering. Both PLA and CobRA have uncertainty filtering to tolerate the impact of uncertainties. Both PLA and CobRA use Kalman filter to dynamically adjust parameters system model based on the observation and posterior validation of the managed systems in current execution. CobRA starts off at the same point using Kalman filtering to handle this uncertainty. Where it differs is that it directly adopts the ideas from the control theory. So, from here they start to answer their two questions. How do the three modules of PLA contribute to its effectiveness in supporting self-adaptation? And how the different design choices in system modeling, environmental predicting contribute to the different performance of PLA and CobRA? For each of these questions, they establish several forms of PLA and CobRA to effectively answer the questions posited, each with different modules based turned on or off to be able to establish what effect they were having. For PLA, they established 4 modules compared to each other, and then established 4 different module layouts of CobRA to be able to compare to the similar layouts of PLA. The 3 major takeaways that they received from all these tests were that the imprecise system modeling can be compensated by uncertainty filtering to some extent. Environment predicting is less effective than precise systems modeling and uncertainty filtering. Uncertainty filtering has a larger impact on self-adaptation's performance than the other 2 modules in handling frequent environment changes. My biggest critique of this paper is that throughout most of it explains very simple concepts of self-adaptation, like the MAPE-K loop and other systems like that, even though identifying in the end that currently this area of study is a hotbed for modern computing and research ideas. Explaining the ideas of PLA and CobRA is fine, but going into extensive detail about how standard self-adaptation works, going to the point of showing diagrams of the MAPE-K loops and an example of a server spooling up more servers, as a self-adapted system spooling up servers up and down, I would assume the reader would have to understand these basic concepts of self-adaptation and give a quick explanation of proactive self-adaptation and moved on, rather than spending a significant amount of the paper going through explaining these minor concepts from the start.